Good afternoon, sir. I'm Charan from Group IR7. Our project is image retargeting, and this is our team. I will be covering the problem and how image retargeting solves it, and also briefly touch upon the procedure and approach, different kinds of approaches to image retargeting. To begin with, advances in imaging technology have made the capture and display of digital images very easy. Nowadays, a variety of displays are being used to view them, ranging from high resolution monitors to low resolution mobile devices. And images often have to undergo changes in size, shape, and aspect ratio to adapt to the resolution of these different displays. And also, displaying and printing documents with embedded images frequently needs resizing the images to comply with the overall layout of the document. Straightforward image resizing operators, such as scaling or cropping, often do not produce satisfactory results since they are oblivious to image content. These straightforward image resizing operators, such as scaling and cropping, often have drawbacks. To list a few, when it comes to cropping, this saves the image detail, but we definitely lose the image content. When it comes to scaling, this operator produces satisfactory results when the aspect ratio of the image doesn't change, but otherwise, the shapes and sizes of the objects in the image are messed up. We can say that they are actually distorted. Another famous approach is letterboxing, which is the padding of images with black bars, but this might be done better because we are putting redundant info into the image. Let us now look at a demo of these operators. Yeah, moving on to the demo, this is the original image. I'll be showing how cropping and scaling work on these images. Yeah, this is the code. The original image is of dimensions, I think it's 200 comma 460. Yeah, I'm resizing these images. This being the original image. This is the cropped version of the image, and this is the scaled version of the image. As I mentioned previously, cropping the image will be losing the image content, but the detail remains same. Scaling here produces like it tints the objects, like the objects are distorted, which is clearly visible. These are the major drawbacks using these approaches, and we will shortly move on to seam carving, which is a better way of resizing images. And I'll also be explaining how a seam carving works. Is there a better option? Something that preserves both the image detail and the image content. One naive approach is to give the users an option to select important regions and selectively scaling those unimportant regions, where the region of interest in the image is preserved. This approach is called selective scaling, but as it is quite evident, there is a lot of manual human intervention in this procedure, which sometimes makes this hard to work with. We will now be moving on to content-aware resizing of images. And in content-aware resizing of images, this is the generic process followed. We have the input image and we compute the importance map. We apply the retargeting operation, and finally we get the output image. And one of the most famous image retargeting algorithms is seam carving. Seam carving is a generic image processing algorithm that was introduced fairly recently, that is like 10 to 12 years ago, that has many other uses other than image retargeting. This method can be used to achieve what researchers call content aware resizing of an image. That is, it can automatically detect the regions of low energy, something like, and remove such energies. Let us look at a short demo of seam carving. Yeah. In seam carving, we remove seams. Seams are one pixel wide path that goes from the top of the image to the bottom of the image. It is like a wavy line that is being shown here. So, but the seams are okay, but which seams do we remove? Mathematically speaking, we remove seams that are of low cost to the image. The cost being the magnitude of the gradient that passes through that particular pixel. Simply speaking, we pick seams such that removing it should be imperceptible to the human eye. The same concept can be used for horizontal seams, and this approach of resizing images is known as seam carving, which is the fundamental idea for achieving content aware resizing of images. But how does seam carving work? The basis for seam carving is what we call the importance map or the energy map of the image that can be used to identify the regions of importance in the image. This energy map or the importance map can be obtained by various methods, but we have used the gradient magnitude approach in our implementation that uses the Sobel gradient of the image to create the importance map. Let me show it to you right now. I've used the same input image that I have shown previously. So this is the black and white image of the input image, and this is the final importance map of the image that is obtained by the Sobel gradient magnitude of the image. This is the Sobel in the x direction, and this is the Sobel in the y direction. Uh, Pixels that have a high gradient magnitude are considered important and are not part of the seam removal process. Pixels with low gradient magnitude are the ones that can be removed from the image without much noticeable difference in the detail of the image. Okay, now let us move on to the demo of our implementation that performs seam carving on the same input image I have been using in this presentation. The original dimensions of the image are 200, 460, and the final dimensions are 200, 200. So, uh, as you can see, the algorithm identifies the seams with the lowest energy and removes them, and repeats this process until the dimensions of the image are same as the required output dimensions. Since the input dimension is 260, 400, I'm removing 60 seams in the horizontal direction and 200 seams in the vertical direction. So as you can see, one more thing to mention is this approach can be used for upscaling of images too, and the process is same. The algorithm picks out the lowest energy seams and puts in new pixels in the place of this chosen seam by choosing the average of the neighborhood pixels, and repeats this until the required dimensions are achieved. It's about to reach completion in the horizontal direction. It'll now be moving on to like compressing the image in the vertical direction. Yeah, so that was the demo of our implementation. Now let's compare the traditional methods of resizing and seam carving outputs. Yeah, so this is the original image, and this is the cropped version of the image, and this is the resized image, and this is the version obtained after seam carving of the image. As you can see, the cropped image, we lose most of the image content. And while when it comes to resizing of the image, the shapes in the images are distorted. And as you can see, seam carving produces the most visually appealing output of all the above mentioned methods. We also have a Matlab implementation of the same, which follows the exact same algorithm and the exact same steps. With this, I'd like to conclude our presentation. I'd like to conclude our presentation by showing some sample images after performing of seam carving. These are some of the sample outputs. This is the upscaling done using seam carving, as you can see. This is the resized version, and this is the resized version obtained after upscaling the image using seam carving. This is the seam map. This is downscaling of the images. This is the same downscaling of the images is also being shown here. And with this, I'd like to conclude my presentation. Thank you.